So let's have a go at this question here. Example number 27. Let me just move that, I'll give myself more space. So we've got the lengths of trout in a fish farm are normally distributed with a mean of 35, standard deviation of 6.1. Find the probability that the trout is less than 35. So for A, we need to say that X is the length of a randomly selected trout. How is X distributed? Normally?
39. 6.2 squared. 6.1 squared.
Arshan, can you stop talking to me? So we want the probability that X is less than 35. Let's do it on the calculator. Menu, probability, distributions, normal distribution. We can start off at 0 and we can go up to 35. We have a mean of 39 and a standard deviation of 6.1. So we get 0.256. B. Cliff catches 5 trout in an afternoon. Find the probability at least 2 of the trout are more than 35. So what is the random variable here? What? The length of the trout? No. What's the random variable here?
The amount of trouts he catches the third.
Can we change the word amount to number of?
Number of.
So the random variable is the number of trout he catches. That doesn't sound like a normal distribution, does it? What type of distribution does that sound like? This is a binomial distribution. So y is the number of trout. Now it's the number of trout. In this particular case, we're counting. So he catches 5 trout. Notice we have a fixed number of tries. We have a fixed number of tries. We have 5 trout. Find the probability that at least 2 of them are more than 35 centimeters. So why is the number of trout more than 35 centimeters? So how is the variable y distributed? It's binomially. What is the number of trials? 5. What's the probability of success?
2.
Yeah. Notice in part A, we calculate the probability that it's less than 35. So what's the probability that it's more than 35?
Not minus 1.
1 minus 0.256. So we can just put it in like that if we want. We don't have to actually calculate it. We can put it in like this. What do we want the probability of for this question? What do we want the probability of?
AISL of the trout more than 35 centimeters.
Which variable do we want the probability of? Which variable talks about the number of trout that are greater than 35 centimeters long? Y. What values do we want y to have?
The values above 35 centimeters.
Nope.
Probability.
It counts. The variable y can have, 6 outcomes. 0, 1, 2, 3, 4, 5. Which values do we want it to have? Sorry? No.
2 or more.
We want it to be 2, 3, 4, or 5. We want it to be greater than or equal to 2. So he catches at least 2 trouts that are longer than 35 centimeters long. All right, have a go at calculating that for yourself now. If you want to get the exact value, this 0.256 is a rounded value. I can scroll up or down here to this point. Watch how I do this on the calculator. If I select this, and then, no, I want to press Control C. So I copy the value.
Oh.
So then I move down here, I can press Menu, Probability, Distributions, and this is a binomial CDF. So B, number of trials, 5. Probability of success, 1 minus, then I can press Control V. Notice I get all of the decimal places. Because I've got my calculator set in float 3, so it's showing 3 significant figures. But when I copy and paste that, I'm pasting the exact value. So the lower bound I want to have here is going to be 2, and the upper bound is going to be 5. And this will give us the exact value. 0.938 is simply the rounded value. If I scroll up and copy that, if I scroll up and copy this down, I get all the value, the whole value. So the one we wanted is 0.983. So it's highly likely he'll catch at least 2 trout that are longer than 35 centimeters. Because that isn't really, that's below the mean. It's very, very likely. Okay, C. Find the probability the trout caught is longer than 42 centimeters, given that it is longer than 40 centimeters. Do I have another space for this one?
Diagrams.
Yeah, we do it here. Now, how do Venn diagrams look for normal distributions? Let's look at the probability curve here for C. So the normal distribution and the density function is going to look like this. So our middle point here is, 39. So we want the point which is 40, that's going to be about there, that's this area. And then we want to find that it's greater than 42, given that it's greater than 40. So this second area is going to look like this. Notice that they overlap. So the Venn diagram for these type of events is this is the all of them. This is how many that are greater than 40. And then this is how many that are greater than 42. It's always going to be inside it. So why am I showing you this? Well, we need to know what the intersection of 42 and 40 are. Notice how the intersection of 42 and 40 is the same probability as 42. So this one intersects 100% here. So when we go for the probability that x is greater than 42, given that x is greater than 40, this is what we want, conditional probability. Let me move that a little bit. So in a normal distribution, with these sort of conditional ones, you're always going to get this happening. They're always going to overlap like this, pretty much. So if they're overlapping like this, that means that the intersection of these two is the same as the probability of that one. So this simplifies it. So we want the probability that x is greater than 42 divided by the probability that x is greater than 40. Because on the top, we would normally want the intersection of the two, but that's the probability that's greater than 42 is the entire intersection. Have a go at trying to calculate this using your calculator. Let me pause the video for a minute, give you a chance to do it. All right, so we want these two probabilities. So let me take this one. So this formula here, I can sort of just edit it a little bit. If I want to select things, I can sort of go into here. I can change this to being greater than 42. Oh no, that one's the mean. So here I'm looking for everything that's less than 42. That's not what I want. Let me start this again. Menu, probability, distribution, normal CDF. Our lower bound is going to be 42. Our upper bound is going to be 100. Our mean, population mean is 39. Our standard deviation is 6.1. So this value here gives us greater than 42. I'm going to scroll up to that one. I'm going to press Control C, copy it. And then I'm going to come here. I'm going to put in my quotient. I'm going to paste that one, Control V. I'm going to go one below and I'm going to paste it here, Control V. I'm going to change that 42 to a 40. Sorry, sometimes my thing repeats the delete many times. So Control V, let me try one more time. There we go. So we've got greater than 40, greater than 42, and we should get our probability 0.716. Notice that I'm taking a great care of detail and effort to make sure I always get the exact values. Because if you're carrying forward on questions, you have to always carry forward the exact values into the next steps. Some of the most difficult questions at the end of a paper, especially paper 2, they're testing that you can do this, that you can carry forwards and you don't just sort of write down approximated answers. Okay, let's have a look at D.
So you're gonna go to the bathroom?
No.
Okay.
Let's have a look at question D.
So it's an emergency.
We're in the middle of this. Can I finish this question? Determine if events L is greater than 42 and L is greater than 40 are independent. So what is the test for independence?
Mutually exclusive.
What is the test for independence? Not quite, almost.
The intersection of A and B can't be equals.
So,
Has to be equal to 0.
no?
No, it has to be equal to the
The probability of the intersection has to be equal to
times A times
the probability of A
times
times the probability of B. So, what would that be in this case? What is the intersection? What is the intersection of the random variable being greater than 42 and greater than 40? What is the intersection of these two?
100%.
The intersection we've already seen in this previous question from this diagram. This is the intersection. This is the intersection. There's no way this is going to be true, you can see already. So for us in this case, this probability is going to be the probability that x is greater than 42. This probability is the probability that x is greater than 40. And this probability is going to be the probability that x is greater than 42. So there's no way, unless we're multiplying by 1, that these two are going to be the same. But what you should do for this question is you need to show your values. So let's calculate the different values. So the probability that it's greater than 42 we have is 0.31. 0.311. And then we just need to calculate the probability that it's greater than 40, which is 0.435. We show that these two are not equal. So we take this number and we multiply it by this number, and we get 0.135. Make the conclusion